analysis. So we have this nice little model, and it has lots of little muscles to it. Charles Atlas once was asked, how did you get your giant muscles? And he said, I started with 42-pound weakling muscles and built them up. So this model actually has a lot going for it. This model has a lot of the key essentials right here. We've done sort of a tour of essentials, but let's see how sensitivity analysis works. Now, that's a good lesson. So all of these experiments are plain old simulation experiments. Sensitivity analysis is different. These experiments run main a single time. And that's good, but sometimes you want to run many times, right? We want to see results over many iterations of the model. So how would we do that? Well, let's go do it. Let's go do it. This has some finesse to this. And I am tempted to refer to some past ones, because there's I may just wing it, but it is nice if one can have a bit of guidance on this, but I guess not. So yeah, I'll wing this too. Okay, fine. So we want to add parameter variation. We want to add a sensitivity analysis to this. And the way to do it is for a parameter variation experiment. So we're going to add a sensitivity analysis involving some of these here parameters, say contacts per day or mean infectious period in days. How are we going to do that? Well, first, a good way to do a sensitivity analysis is to use a plain old parameter variation experiment. Should be available in any version of any logic, and we're going to say finish. Here's a parameter variation experiment. All right. So this is going to run the model with different assumptions, either about parameters or run it many times for summarizing its variability due to stochastics. So I'm gonna do the first one fast, not scholarship. Too many reference letters due tomorrow. I'm gonna say stochastic parameter variation, not parameters variation. I don't know where that came from. Parameter variation. Okay. Gives me the willies. Okay. So I'm going to run it in a fashion that's free form. I'm going to say I'm going to run it 20 times. Let's say I'd run it more, but we have limited time together. Okay, there we go. 20 times. And this first one is just going to run it 20 times, and it's going to observe the variability in the results over those times. Okay, so let us go. Yeah, nice. Okay. So we're going to. So this is a experiment. It's an experiment like these, but it's different in a key way. It's going to run the model 20 times here rather than once, as this does. And the stochastic one is going to run it with these parameter values. If I wanted to vary the parameters, I could do so here, and I could say, range or what have you. But for this particular one, I'm going to do it with stochastics first. Now, if I run this, it will actually run, but it won't be terribly enlightening. I mean, we'll run it, and lots of exciting little things will happen, and things flashed and so on. But there's it kind of leaves you an empty feeling, because it's full of sound and fury. It's running it again and again and again 20 times, but where's the outcome, right? Where's the output from it? I want to see something about the results of the variability. And to get the goodies, you need more mechanism, and I'm going to show you how to put that mechanism in. Forgive the lapse from the King's English. Okay. So right. Right. Okay. Okay. Good. Okay. Right. Okay. Okay. Sorry. A bit of needs here. Okay. So, what we're going to do is we're going to observe within this parameter variation experiment information collected from the model every time it runs. Okay. And so each time we run it, we're going to collect some information from the model. And basically, it's going to run it 20 times. And after each of those 20 runs, we are going to go and record these things. So let's go do that. So I'm going to go to the palette, and notice I'm editing here, not main, not person, but I'm actually editing this experiment. I'm putting things into this experiment. What am I putting in? I'm putting in a palette. Okay. And I'm going to put in to the palette a mechanism to collect data. And here you are. Right. So this is going to be a data set. And this data set is going to be called cumulative infectious incident case count. Okay, and it's going to be a sort of a final value for it. This is going to be sort of the easier one to look at. How each time we're running the model, each time we're running main, remember this runs main 20 times. Each time it's going to grab this out, this guy here, and it's going to add it to this data set in the experiment, in the scenario, because the scenario is running it 20 times. Each time it runs it, it'll salvage it before it disappears. So after it's run, it'll salvage it. It'll stick that value into this data set, and then it'll continue and continue and continue. So this should be really called cumulative infectious case count data set. Okay, fine. And here, we'll have number of completed iterations as horizontal value. That's exactly right. And okay. Okay, so yeah, fine. And the vertical value will be given by well, we're going to go actually add this in here. So each time it runs, we're going to stick it in this data set, and we'll only keep 100 for now. Okay, fine. This is one time where I won't rail against the machine. Okay, fine. So I'm going to scroll. I'm going to click on this this thing here, and I'm going to scroll down. Yeah. And this is where you want to put it after iteration. Okay. And I am going to say here, cumulative infectious case count data set add, and it's going to let me add a value. And what value is it going to be? It's a value from the run I just did. And I thought normally they have a little this. Oh, you know what? This should not be after iteration. I think it should be after simulation run. I'm sorry, after simulation run. And you notice there's this little thing, and it says refer to root as the top level agent. So that's the thing we just ran. That's main. It's the main we just ran was called unceremoniously root. Okay, so it's called root. Okay. And so we're going to get out of root. Well, root is referring to the main that just ran. So we're going to get cumulative infectious case count at the final time. Okay, there we go. We salvaged it just before it's going to disappear. We ran it, and we read the value out, and we stick it into this value that lives in this parameter variation experiment, and therefore lasts between many of these. So it's going to run main. It's going to rescue this and stick it in here. It's going to run it, rescue it again, stick it in here, run it again, rescue it, stick it in here. And it's going to get it in there. Okay, let's go see what happens. Oh man. Yeah, I know it's a bit of mechanism and it's kind of annoying, but let's go see what happens. Now it has 20 samples in it. Now look at that. They're all 75. Okay, what gives? Well, guess what gives? You want to guess what's wrong here? Guess what silly thing is wrong? Does anyone want to guess? Where have we seen the same numbers turn up every time until we change something? Where did we see that before? Sella is once again on top of it. It's the random seed. Look at this silly thing. It's set to a fixed seed. Why they did that by default, I have no idea. Random seed. Random seed now is what you want. Random seed. Okay. We're going to run it. It's running it 20 times. Boom, 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 boom. Now it has different values there. And you look, different runs have quite a variety of different values. It's kind of bimodal, is it not? So I was looking for my, here it is, trusty spreadsheet. Let's go paste it in there. Look at that. You know, a few have very, very few, but most have around 80, you know, something in the 80s. Here's 178. One as high as 88, and one as low as 78 here. But then you get sort of very bimodal. Now, if we want to run it more than that, we of course could. So we could run it here, not just 20 times. We could run it 200 times. Since it's so lickety split fast, we just need to keep more than 100 samples. I'm going to put this at 1,000, up to 1,000 samples. And we could run it. Oh no, I didn't mean to debug it. Oh man. Okay. Well, I'm gonna stop that to avoid confusing you. Okay, fine. Here we go. And there we go. Okay, running. And here we go. Boom. Run. And so here's a summary of 200 runs. This first thing identifies what iteration. Here's, the results. And, if you wanted to, you could go take this and you could stick it into R, right? And get a nice little data set and plot it as a histogram. And that would be a a good thing to do. You'll notice it's quite bimodal. Now, if you want to do something a little bit slicker, and I think we could do it. I'm going to stick in right here, this very place. I'm going to stick in a histogram data object. Here we go. So cumulative infectious incident. I'm just going to copy the name. Here we go. So histogram data. Histogram data. Boom. Okay. And so we'll have 10 intervals. Fine. It will detect them automatically. And I don't want it to update automatically. I will update it manually. And where will I update it? Yeah. I will update it exactly where I updated the other ones. There we go. There we go. Oh my gosh. I'll update it right here. Yeah. Okay. Cumulative data. So now we're adding things in. We're adding the same value we read out to this to put it in a histogram. Okay, we're going to put it in this histogram data. By the way, you can do this in the main model too. It's great. You can have histograms of things. You'll find them on my example models. Okay, so what are we doing here? Well, one thing is we stuck it into the data set. The other is we're sticking to this histogram data. And all we need is now, since we have a histogram data, we could put in a histogram. And it will, guess what, get its data from the histogram data. So there's this, and that's the histogram data. And then we can go like this, and we'll call it the histogram. And we'll say this is cumulative case count, cumulative infectious incident case count. And the histogram, you refer to this histogram data object we just created there. Okay, great. And we're in good shape now. So what did I do? Let's go back. All I did is I went here and I added this line, and I'm going to put it on the full screen. We have two lines here, and they're basically doing variants of the same thing. They're just reading the same value out. This is the same value both times. It's reading it out of main. It's reading this value. Each time it runs main, it reads this value out at the final time. Okay, and what is it doing with that? Having read it out, where does it go? Whither does it go? It puts it in one case into this data set. That's what we were looking at earlier. That's what we pasted into here. This data set, which recorded one by one the value. And this other time, it puts it into this histogram data, which is going to allow us to then have this histogram, which refers to this histogram data. It divides it up. This is a histogram data object, and this is the histogram, which depends on it. So if we were to run this now, with it running it 200 times, it is going to show us a bimodal distribution. Most of them are between, this is around 70 something to 100, right in this range, and some are around 0 to 20, something like that. And if we wanted to run it even more, we could do that, and we would probably get, I'm gonna do 1,000, sure. And here I will allow it to store, it's not, it doesn't have a limit, and this stores up to 1,000. So sure, let's go run this, and we'll run it 1,000 times, and there we go. Hey, come on. Okay. So it's summarizing 1,000 runs of this model, and you can again see it's very bimodal. It's just a little bit, maybe in the range of 100, quite a bit down here, which never take off. Okay. So that's some parameter variation. Now there's another final bit which I kind of feel impelled to do. And again, I'm doing this kind of seat of my pants here if I feel following my nose, but I'll try to do this other one too. So I'm going to take this one step further. I am going to show, so this showed a summary value at the end, and that's pretty good. Often we're interested in the final attack rate or whatever, the final summary. But sometimes we want to see the trajectory along the way. And we actually have that in Maine. We had this data set right here, this weekly infectious incident case count data set. How if we plotted that out over time? Wouldn't that be kind of nifty? This is a bit trickier, but I'll see if I can do this here. Okay, what do we need? We need something you haven't seen before, and therefore I'm attracted to, because I want to show you the nifty things. This one's very useful with parameter variation experiments, regardless of whether they're based on stochastics or based on actual genuine variation of parameters. Okay, what is this thing? I'm going to read it out and I'm going to put it into a 2D histogram. A 2D histogram, ladies and gentlemen, is going to summarize for different points in time the value, the range of within what ranges different runs fell. So we're going to actually see a kind of curve over time from this, similar to what you would have observed when we ran parameter variation in any Logix built-in model, which I suspect lies at the basis of Sala's request to be able to do this on your own. So I'll show you how you can do it on your own if I can do it by my nose right now. So what you want to do is you're going to go through the same basic gist. The only twist is you're going to have a 2D histogram object, 2D histogram data and 2D histogram, rather than a histogram data and a histogram. This is a 1D histogram. Shows in 1D for each of these bins. You get a count. 2D histogram is going to have bins on the x-axis, bins on the y-axis, and you're going to have, it's almost like the squares are darker if lots of things have fallen into there, and you'll be able to project out trajectories, for example. That's what you're going to get. Let's see if we can get there. So my recollection is basically you do this. 2D histogram data, and we'll say this is, what is this thing called anyway here? It's called weekly infectious incident case count data set. Okay, fine. So we're going to go back to this. And so what did I do? Well, I dragged in a histogram 2D data, just like I started before with a histogram data and then built a histogram based on it. I'm going to do a histogram 2D data. And by the way, this needs values put into it. We put them in after the run of main, and this will need similar things, but we're going to stick a whole data set into it. Okay, how are we going to do this? Okay, we're going to do the following. Weekly infectious incident case count, and we're going to do 2D histogram 2D data. Histogram 2D data. I know that's a mouthful. I'll put it in full screen mode. Even that's not big enough. Okay, fine. I'll put it into. Here we go. Yeah, sure. So this is what I called it. Come on. Oh, don't tell me. Oh man. Okay. Wait, wait. Okay. Sorry. Okay, run. What is it? We'll do it. Kate, maybe Kate will do it. Okay. Fine. And oh, don't tell me you won't do it too. Okay, get it. We'll do it. Sorry, folks. Oh, nah. Okay, well, you could see it there. Okay, fine. Okay. Weekly infectious incidence case count 2D. Case count histogram 2D data. Okay, this has got it kind of long. I'd probably call it like weekly incidence 2D data, histogram 2D data. That might be better. Yeah, sure. We'll call it that. Weekly incidence histogram 2D data. I kind of like that better. Okay. Great. Okay, so we stick that there. Okay. Okay, fine. I'll do number of intervals. Yeah, sure, 20. Number of intervals, y. Yeah, okay. I'll say do not update data automatically because I'm going to do it by myself. Great. Okay. So this is the 2D data. Make sure you copy it. And by the way, we're not filling this in right now because we're going to be doing it manually. Okay, great. The next thing we need, and we're going to complete this little part of it, is this little sort of user interface part. We need a histogram 2D. This histogram 2D is going to depend on this guy. So this is going to be weekly incidence, and it's going to depend on this 2D data set. And the name of this is going to be here. It's going to be that 2D, histogram 2D. Oh boy. Yeah. Okay. So what's going on? Basically, look, we started with a data set and we added things to it after we ran main, and we got some values, and we saw how they where's my spreadsheet? We saw how they varied. Then we added a histogram 2D data, and we added the data to that, and for the final time, the same sort of value we added here, and we made this depend on that, and that plotted out a nice histogram, and that was sweet. For this, what we were doing is we're going to do something similar. We're going to add data into this and make this depend on it. But what are we going to add into here? We're going to have a whole data set. So we're going to be adding each time we run the model, not one value at the final time. We're going to be adding a whole trajectory of values as recorded in this guy here, this guy. So that's what we want to add into there. Yeah. Okay. So let's go do this. We're going to add it in to this one. Okay, so we need two things kept around to write the code. We just need this. This is the thing we need to read out of root, out of main. When main finishes, we want to read this thing out of it, this data set. Okay, that's one thing we need. Fine. The other thing we need is this. This is what we're going to add that data into what we're going to add that data. So basically, this thing is going to add this. We're going to add this into it. So this thing is going to accumulate these trajectories. This holds trajectories after each run of main. this holds a trajectory of what the case count was over time. And each of those trajectories will be added in successively to this, and we'll display it as a 2D histogram. There'll be darker things where more runs fell, and lighter things where few runs fell. That's the goal. Let's go take a look. Okay, fine. So we got to go down here, and let's go to the salt mines. There we go. Okay, and so what we're going to do is we're going to do this dot add, yeah, and we add in a data set. There we go. And what data set is it going to be? This be the data set, like that. Okay, I'm going to put this in the for those who are having trouble following this, I'm going to put it in the chat. There we go. It might help to make it quite broad screen. Okay, so let's see if this builds. Oh, it actually builds. Okay, that's great. Great. And now I'm going to try to run it and see what happens. And I may have to adjust some of the settings to kind of get more bins or something like that. But, okay, so this is kind of still nicely working. Okay, this isn't so nice because evidently the bins are wrong. Okay. Let's go take a look at this. Okay, so yeah. Okay, so it looks to me like it looks like it's not having enough values there. All of the runs are falling into this tiny trajectory, basically, the weekly incidence. And I want to see why this is. So I have a feeling it's not running it long enough. So this is running it for 100 days. Whereas here we ran it, well, we didn't really run it with a stop time. 100 days is going to be about 14 weeks, which you would think would be enough. So I don't think that's it. I'm wondering if it's something to do with the bit. Here we go. Okay, there's the problem. The fox has shown its tail. So basically the range for X values are too small. And it's going from 0 to 1. We instead want it from 0, say, to 14, 14 weeks, because 100 days is just over 14 weeks, which is 98 days. And the Y value range, it's not from 0 to 1. The Y value range goes from like 1 to 50 or something. I think it went up to. Okay. Let's try that. I'm gonna make it more fine-grained. I'm gonna do well, fine. I'll leave it like that. Oops. Okay. So that was that. So that's good. I changed these number of intervals for the X-axis range, 20 from 0 to 14. This 20 from 0 to 50. Okay, fine. And this just depends on that, and I think that will be okay. Let's run this. Not sure it will work, but it might need more futzing with the values. Okay. Yeah. Okay. So happy. Okay. Well, this looks a lot better. Okay. So it's obvious it's only running. It looks like it's running. Okay. Okay. I know what the issue is. Yes, of course. Oh gosh. Yeah. Okay, fine. Because the X-axis is not weeks. The X-axis is days. And what this is running, when we run the model once, what we see is, yeah, when we run the model once we see this being accumulated every week, and it's 7, 14, etc. 77, 10, and so on. So we need this to go much further. We need basically this to go from 0 to however long this run goes, which is 100 days. Here, 100 days, stop at specified time. So we want this to go for, let's say, 100 days. And yeah, sure. And there we go. And let's try this. Okay, yeah, okay. Thing of beauty. Okay, there we go. Okay, so what is this telling us? Well, it's telling us is we just run this simulation with stochastic variability. There's variability between runs, but there are some runs which seem not to take off. They still stay persistently low. It's not a huge number, but it's sort of blue all the way to the base. Most take off, and most take off fall and around this time within this range, and this time within this range. We should go a little bit higher here to allow it to capture it. But then virtually all come down to these very low levels by time 30 something, and then stay low. Now we can make this a little bit prettier by breaking this up into more intervals. So maybe I'll break it up into 50 intervals on the vertical scale, and probably I should have made it a little bit wider here. Instead of y-axis 0 to 50, maybe I'll make it 0 to 100, and maybe I'll make it 100 scale. That's fine. That might be too fine grained, but we'll try it. Okay. Okay, and there we go. There we go. Look at that. Okay. So a fuller picture emerges. Yeah, we have the biggest range right here. At around time 14 by it looks like. This is probably 7, this is 0. This is probably 21, 28, etc. And we see runs kind of going up, being around here and down. Now, because Salah's question asked about the effects of sensitivity of parameter variation, I'm not sure which he was interested. I'm going to copy, I'm going to paste, and I will just note that was stochastic, but now I'm going to say parameter sensitivity, and I'm going to vary in contacts per day, and I'm going to vary in range contacts per day from a range of 1 to a range of 10 with a step size of 1, and then for each of them, I'm going to run it for 10 replications, so that it runs it many times for each of these values. Maybe I'll do it a step size of 0.5. Fine. So it'll go start at 1. It'll go to 1, and it'll run it for 1 10 times, and then it will run it for 1.5, and it will run it 10 times, and it will run it for 2, and it will run it 10 times, etc. So there we go. This is no longer a stochastic one alone. We're varying the parameter contact rate, and let's go see what change it induces. Okay, And what we see is induced by this. Look, even for variation in that contact rate, you basically see a similar pattern, but where the range of variation is much larger. It goes from as low as this to a high. So you see there's quite a few more values because of low contact rate, and quite a few low values that stay very small, and don't get high. You see a bigger range here because there are probably some chance, even with higher contact rates, there's probably some chance that it'll be a bit lower, and some chance it'll be higher even with somewhat lower contact rates. But variation in the contact rate really spreads out this the range of this. Okay, and some keep it alive for longer. Okay, okay, ladies and gentlemen. Wow.